And welcome back. We are going to now go ahead and take a look at divide and conquer algorithms because we're going to go ahead and use this to help us develop better algorithms that can be used for specific cases such as sorting. So before we go ahead and develop algorithms, the first thing we have to wonder about is how we can start finding patterns in our code. Patterns, of course, are in this case design outlines that can apply across a variety of software applications. And typically, to be useful, the pattern must apply across a variety of situations. It's not necessarily tailored to one specific case. And to be substantive, the pattern must make some assumptions about the domain of applications to which it applies. One well-known example of a pattern is known as the container iterator pattern. A container is a class or some other construct whose objects hold multiple pieces of data. An example of a container is an array, because we can hold, for example, multiple integers, multiple doubles, multiple strings, class types, etc. So let's talk about the container iterator for a second. Any class or any construct designed to hold multiple values can be viewed as a container. A string value can be viewed as a container that contains the characters in that string. Any construct that allows you, therefore, to cycle through all the items in a container is an iterator. So, for example, an array index would be an iterator for an array. It can cycle through the array as follows. So if we say like for in I, and I is less than a of the length, I plus plus, do something with a of I, we can say that the variable I is our index variable for our iterator. The container iterator pattern describes, of course, how an iterator is used on that container. Now this is going to lead us next to something known as an adapter. The adapter or adapter pattern allows us to transform one class into a different class without changing the underlying class, but merely by adding a new interface. The new interface therefore replaces the old interface of the underlying class. We see this, for example, in the stack data structure, which is used, among other things, to keep track of recursion. One way to keep a stack data structure is to start with an array and add the stack interface. An adapter array says, hey, start with a container, such as an array, and then add an interface, such as the stack interface. So if we start looking at this model view controller that we're starting to work with here, this is a pattern that we can use that's a way of separating the input-output task of an application from the rest of that application. The model part of the pattern performs effectively the heart of the operation. The view part of it is the output part. It's giving us a picture, whether that's through text or GUI or something like that. The controller would be our input part. It relays commands from the user back to the model. Now normally each of these three interacting parts is realized as its own object with responsibilities for its own task. Now because we can kind of say each of these are own tasks, we can use what's known as a divide and conquer. The model view controller pattern is an excellent example for looking at the divide and conquer strategy because remember we have three distinct parts here that work together, but they effectively kind of do their own thing. One big task is divided to three smaller tasks with well-defined responsibilities. So even though this is a very simple example, we can say like, well, our model might be a container class such as an array. Then we can say, hey, the view might display an element of that array. Controller will allow us to give commands to display the element at a specific index. The model, of course, would notify the view to display a new element whenever the array contents change or a different index location is given. Now, any application can be made to fit the model view controller pattern, though it is more suited well to GUI type applications because we're going to be working with something that people see. Because the view part of that is a visualization of whatever state of the model that we're using. Now, the model in this case might represent an object, let's say, of your computer desktop names. The view could be a GUI object that produces a screen display of your desktop icons, and the controller could relay commands to the model, which is our desktop object, to add or delete names. The model object then notifies the view when the screen needs to be updated. Now this is not just applicable to, obviously, this example, but let's do this something we might be a little bit more familiar with, which is sorting. So one thing you have to understand about sorting is efficiency is very key here. And most efficient sorting algorithms all seem to follow a similar pattern. When we express these patterns recursively, what tends to happen is they divide the elements to be sorted into two small lists, then recursively sort the two small lists, then recombine the two sorted lists to obtain the final sorted list. This pattern is expressed as pseudocode, and we're going to see here, in fact, almost all correct Java code when we take a look at it, for a method to sort an array into increasing order using the less than operator. So if we look at that pseudocode, one of the things you'll notice is we have a sorting algorithm. We're taking in an array type. We have a beginning and ending interval, and we're going to look to see where that split point is. And once we have that, then we can call the sort based upon that split point. So we have the sorting of that first half of the array, sorting the second half of the array, and you'll notice, of course, is we can then join these back together at the end. Otherwise, our else here says sorting one or fewer elements, so do nothing. So if we have an element that is, only, let's say, of size 1, well, we don't need to sort that array because it's only an array of size 1. So this allows us to effectively apply our divide and conquer algorithm. So the sorting pattern that we just looked at uses the divide and conquer strategy. It takes the entire collection of elements to be sorted into two small collections, sorts the small collections by recursive calls, and then combines those two sorted collections back to obtain a final sorted array. Now, although the pattern does impose some minimum requirements on the methods such as split and join, it doesn't exactly say how the methods split and join are defined, and that's important to keep in note here, because the different definitions of split and join will yield different sorting algorithms. The method split, in this case, we're going to rearrange the elements into an interval at a of begin through a of n, and divide the rearranged interval at the split point. The two small intervals a of begin through a of split point and split point plus 1 through a of n are then sorted by a recursive call to the method sort. You'll note that the split method rearranges the elements in the array from the beginning to end and returns an index split point that then divides that interval. After the two small intervals are sorted, the join then combines the two sorted intervals back to obtain the final sorted version of the entire larger interval. Now, you'll notice that the pattern says nothing about how the method split rearranges and divides the interval from the beginning to the end. In a simple case, split might simply choose a value split point between beginning and end and divide the interval into the points before a split point and the points after a split point with no rearranging. On the other hand, that method split could do something more elaborate, such as move all the small elements to the front of the array and all large elements toward the end. And this right here would be a step on the way to fully sorting the values. And we're going to take a look at next some algorithms, some newer sorting methods that we can use besides the previously defined bubble sort and selection sort that we have looked at.